Hello everybody, welcome to Guidancee Education channel. We will see the topic that is discussed in this video. We are continuing class 11 physics, thermodynamics. We will discuss thermodynamic equilibrium, equation of state, classification of state variables, check consistency of thermodynamic equation with classification of state variables. This video will be of great use to you, so watch the video completely without skipping. And if you think the video is useful, do like the video, share the video, and also leave your comments in the comment box below. If you have not subscribed my channel, do subscribe it now and also press the bell button and all button for notification of more videos like this. Thank you very much. Let us see the topic. Let us take up the first topic, thermodynamic equilibrium. When do we say that a thermodynamic system is in thermodynamic equilibrium? It has to satisfy a few points. First thing is, the state variables should be constant. That is, the state variables which depend upon only the initial and final state of the thermodynamic system, like pressure, volume, temperature, etc., should remain steady. They should not change. That is first condition. Second one is, the composition should not change. It should be constant. What does it mean? Let us suppose the system contains a mixture of substances. Then the composition, that is the ratio in which the components are present, should be constant. It should not change. That is the second point. Now let us see the third point. The system should be in chemical equilibrium. If a reaction is taking place in the system, then the rate of the forward reaction should be equal to the rate of the backward reaction. And the concentration of the equilibrium mixture should remain the same. It should not change. That is, the amount of products and reactants present in the system should be constant. That is the meaning of this. What is the fourth one? The system should be in mechanical equilibrium. What is the meaning of mechanical equilibrium? It means all the forces acting on the particles within the system should be balanced. That is, the particles should not experience any acceleration. Okay. Now, thermodynamic equilibrium is described by its state variables. Different thermodynamic systems, that is thermodynamic system number 1, thermodynamic system number 2, and so on, can be in different thermodynamic equilibria. That is, thermodynamic system number 1 may have a certain set of state variables, and thermodynamic system 2, 3 or 4 may have their own state variables. But the only thing is, those variables for those particular thermodynamic system should remain constant. So that much about thermodynamic equilibrium. The second topic is equation of state. We already know the gas equation. PV is equal to mu RT. Certain books give it as nRT, where mu is the number of moles. For 1 mole, this equation becomes PV is equal to RT. This is for 1 mole. Okay. This equation shows the relation between the state variables P, V, T and mass M. Here mass is given in moles, that's all. So in thermodynamics, this equation is called equation of state. It is very simple. I hope it is clear. Classification of state variables. State variables are broadly classified into two: extensive state variable and intensive state variables. What are extensive state variables? Extensive state variables depend on size, that is mass, volume, internal energy. They are all extensive state variables. Intensive state variables do not depend on size. Pressure and temperature are intensive state variables. Let us understand it better. Suppose we have a system and it is described by the state variables mass, volume, internal energy, pressure, temperature, etc. This system is in thermodynamic equilibrium. If such a system is divided into two, this system is partitioned into two equal halves. The magnitude of which state variables will be affected by this? Mass, volume and internal energy will become half that of the original. So we understand mass, volume and internal energy depend upon the size of the system. But pressure and temperature of the two systems remain the same and also the same as that of the initial system. So from this we understand pressure and temperature are state variables which do not depend upon the size of the system. Why is it that pressure is not changing? The reason is pressure by definition is force per unit area. So it does not depend upon size. Now let us talk about temperature. Why temperature is not changing? Temperature is the degree of hotness of an object. If you have 100 cc of water at 100 degrees Celsius and if you partition that into two equal halves having 50 ml each part will have temperature equal to 100 degrees Celsius. I hope it is clear. Now let us check the consistency of thermodynamic equation with classification of state variables. What is the thermodynamic equation? Delta Q is equal to delta U plus P delta V. Q is quantity, so it is extensive function. That is extensive state variable. U is internal energy. It is also extensive state function. P is intensive, but V is extensive. But the principle is intensive function multiplied by extensive function is equal to extensive function. Therefore, this quantity P delta V is extensive. So we find all the quantities in the thermodynamic equation are extensive. So the thermodynamic equation is consistent with classification of state variables. I hope it is clear. I hope this video was of great use to you. Please like the video, share the video with your friends and also leave your feedbacks as comments in the comment box below. And subscribe my channel and also press the bell button and all button for notification of more videos like this. Thank you very much for your support. We will meet in the next video with another important topic like this. Till then, bye. Take care.